Today's topic is calculating properties of motion. So what we've done so far is we've looked at what are the properties of motion, how can we represent these properties on a graph, and next we're going to look at using a mathematical formula or an equation, how can we calculate these properties if we know other properties. The first thing we need to know in order to be successful calculating properties of motion is we need to know the symbols and what they stand for. So, lowercase v is velocity or speed, lowercase d is distance, delta x is displacement. Delta now is a Greek letter symbolizing a change in, which mathematically that just tells us to subtract. Lowercase a means acceleration, a lowercase t means time, v sub f is final velocity, v sub I is initial velocity, and again, delta is a Greek letter symbolizing change. You must memorize these symbols. Okay. On a test or quiz, you will be provided with an equation chart, or the equations will be written on the board, but the equations are going to be written in symbols. So you need to memorize these symbols and be able to recognize what they mean. Another set of information that you must memorize is the units. Okay, the difference between a symbol and a unit is the symbol is what we put into the equation. It's the variable that represents each property. The unit are the letters that go after the number. So we can have lowercase m, and depending on where we place it, it can mean something totally different. A lowercase m in an equation would mean mass. A lowercase m behind a number is going to mean meters, and it's going to symbolize that we're measuring either a distance or a displacement. Seconds is a lowercase s and is measuring time. Meters per second is m/s, and that's our speed and velocity. Meters per second squared is how we're going to measure our acceleration, and that's represented by writing m/s to the power of 2 after a number. Again, the symbols go into the equations, the units come after the number. So we have to take into consideration the context of where we see these letters as to what they could mean. The third piece of information we need are our list of equations. Okay, we're going to work with 5 equations. I have provided you with the equations both in symbols and in words for the purpose of these notes and for you to use to practice with till you get comfortable. However, when it comes time for a quiz or a test, you will only be provided with the equations in symbols. Therefore, you must memorize the symbols. The phrase I would like you to learn is, in order to pass physics, all you have to do is draw a picture and guess. But there's a catch to that. Okay, scientists don't ever really guess, so GUESS is an acronym to help remember all the steps to solving a problem. I want you to think of your guess methods as a different play. Okay, if we're talking about football and we're trying to get from the 20-yard line to the opponent's end zone, that's about 80 yards. We have very few plays in our playbook, in which we could make it all 80 yards in one play. In general, we rely on continually getting 3 or 4 or 5 yards of play to continually move the first down markers and make progress. And that's how I want you to approach these problems. Just one step at a time. If we continually make progress, we'll eventually reach our goal. But it's very difficult to get there in one fell swoop. So, the first part is to draw a diagram to represent what is going on in the problem. G, we're going to list the given information. This can be from the problem or from the constant that I'll ask you to memorize throughout the year. The two constants you will have to memorize will be the acceleration due to gravity, which is negative 9.81 meters per second squared, as well as the speed of light, which is 3.00 times 10 to the 8th meters per second. We won't get to the speed of light until next semester, though. Okay. As you write down your given information, it's very important that you include the proper symbols and the units for each variable given. The more detailed you are on the first two steps, the easier the rest of the problem will become. Next, we're going to write down the variable that we're asked to solve for. We're going to consider that to be our unknown. Some questions ask for more than one variable, and others imply that we solve for one thing first before we can solve for what it actually asks. Those pieces of information should also be written down in the unknown section. E stands for our equation. So we're going to pick from our list one of the formulas that we have to solve for. We need to keep in mind that we can rearrange or manipulate the equations to solve for the variable that we desire from our unknowns. When we took these notes in class, I gave you several analogies on how to pick your equations. I do understand that this will be the more difficult step for most students and that you won't get comfortable with it until you actually practice. The key to being successful with solving these kind of problems is practice, practice, and more practice. When I was in high school, I played volleyball. If I were to go back into the gym and try and play volleyball again, I would not be as good as I used to be because I haven't practiced. Okay? Same goes for if I were to go and try marching in the marching band. I would not be successful until I could get better with practice, but it would take me some time. In order for you guys to become successful at working these problems, you need to practice, and it will take some time. Finally, we have our two S's. Substitute, which means plug in the numbers, replace the variables in the equation with the numbers that we wrote down in the given section, and then solve. And that's where we're going to complete our algebra or mathematics to come up with a numerical value for our answer. Now we're going to work a sample problem together. This example says the mouse's initial velocity is 4 meters per second and it moves for 2 seconds at an acceleration of 3 meters per second squared. What is the mouse's displacement? So the first thing I'm going to do is I'm going to circle the question. What is the mouse's displacement? In another color, I'm going to underline the important information that's going to help me determine that. So, 3 meters per second squared, 2 seconds, and 4 meters per second are all going to be our important information. In this case, they're all actually numbers. but that is not always the case. Sometimes it may say at rest, comes to a stop, speeds up, slows down, moves from here to there. The information can be represented in many, many different ways. Okay, so next we're going to look at our, we're drawing a picture. Okay, so we have a mouse. We're going to attempt to draw a little mouse. Okay. And our mouse is moving, and he speeds up. So we need to show that our arrows get bigger as he goes along to show that he's getting faster. Okay, the given information from this problem, our initial velocity, VI, equals 4 meters per second. Our time is 2 seconds. And our acceleration is 3 meters per second squared. At this point, it is very, very important that we have our symbol or our variable, or what part of the equation is this representing, as well as our units. Okay. This example has all of our stuff in our standard unit, but this may not always be the case. So we need to write down the unit that it gives us, and if it's not seconds, meters per second, or meters per second squared, then we need to convert and make it so that it is one of those 4 units. Right. The next part is our unknown, and it asks for displacement. So we're just going to put x equals a question mark. I know that it's x because it asks how far did it go. Okay, what is the displacement? We know displacement is represented with an x. Okay. Next, we need to pick an equation. Okay, we have a long list of equations, but if we think about what kind of problem are we solving, well, it's a one-dimensional motion problem. So then we can focus on the one-dimensional motion box of our equation chart. That narrows it down to 5 equations. We know that the object is speeding up, so that our equation has to include an acceleration. The first 2 equations on the equation chart don't include an acceleration, so therefore we cannot use those 2 equations. And there's multiple ways to solve every problem, but the equation that I'm going to choose to do this is I'm going to use x equals VI times t plus 1/2 AT squared. Okay. If you choose to solve this problem a different way, it's okay. It just may require more steps than the way I'm going to solve it. So our first S is to substitute. So we're going to plug in the numbers that we know. Well, we don't know x. We just have a question mark. We don't want to put the question mark into the problem because sometimes we'll have more than one unknown, and that can get a little too messy. So we're just going to leave x. So I'm going to write x equals, for VI, we wrote that it was 4 meters per second. So I'm going to write 4 times t was 2 meters, or 2 seconds, excuse me. So 4 times 2 plus 1/2. Our acceleration is 3 meters per second squared. So I'm going to put in 3. And then our time, again, we're going to use the same time that we used for the first t in the beginning. So then we're going to have times 2 squared. Okay, in this equation, only the time is squared, not that whole portion of the equation. Again, only the time is squared. Okay, so now I'm going to do the algebra. And I get x equals 4 times 2 is 8, plus 2 times 2 for 2 squared is 4, times 3 is 12, times 1/2 is 6. So I get x equals 8 plus 6, so x equals 14 meters. I'm going to draw a box around my final answer. Okay, and then we're done with this problem. Again, the more you practice, the better you'll get. And if you pick a different equation and do a couple more steps than I did, doesn't necessarily mean your answer is wrong, as long as you still end up at the same value that I did and I can follow your work. It is very, 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 very important that you always, always, always show your work so that I can see where your mistakes are and then correct them, as well as if you did it differently, give you credit for still getting to the correct answer.